Okay, before we begin a discussion on geometric sequences, I thought I'd go through a quick review of arithmetic sequences. So if you recall, this is an arithmetic sequence. We start at 5, 7, 9, 11, 13. 5 would be our first term, so we can think of this as each term has a number or a placement in the sequence. 5 is the first term, 7 is the second, 9 is the third, and so on and so on, fourth and fifth, and there are potentially an unlimited or infinite number of terms in this sequence. And you may notice a little pattern here. To go from 5 to 7, we're adding 2. To go from 7 to 9, we're doing the difference, or we're doing the same. To go from 9 to 11, again adding 2. And from 11 to 13, we're adding 2. And this repeated addition of 2 is what we call the common difference. So this is called the common difference. And this is all well and good, but let's say we wanted to predict the 100th term of this sequence. We could add 2 100 times, but it's easier to create a formula that will get us there because then we can generalize that formula to all sequences and not just this sequence. So let's see if we can derive that formula somehow. So let's make a function table. Actually, let's not use x. Let's use n for the term number and a sub n for the actual term. So let me define these variables for you. N refers to the placement in the sequence. So 5 is the first term. So if we were to write if n equals 1, then the first term is going to be 5. So when n is 1, a sub n is 5. And so the second term is 7. The third term is 9. The fourth term is 11. And the fifth term is 13. And in fact, I'm not going to need all of these to show you what to derive the formula. And I'm going to need some space. So let's just use the first 3. So one way of looking at this is 5 is equal to itself. We know that 5 is equal to 5. We can also say that 7 is equal to 5 plus 2, and 9 is equal to 5 plus 2 plus 2. Now, why would I describe the successive terms in the sequence using multiple additions of 2? Well, 2 is the common difference, and the way you generate more terms in the sequence is you just keep on adding the common difference a certain amount of times. And if you notice, to get the second term, we added the common difference 1 time. To get the third term, we added the common difference 2 times. So I'm actually going to write this a slightly different way. Since we're adding the common difference 1 time, I'm going to say that this is 5 plus 2 times 1. And if we're adding the common difference 2 times, I'm going to write this as 5 plus 2 times 2. And just to remain consistent, I'm going to write this as 5 plus 2, and since we're not adding the common difference at all, this will be 0. So now I want to ask myself the question, if I want to predict any term. So let's say, instead of the term number being 1, 2, 3, let's say the term is just n, an unknown term. Then a of n, the term, would be what? Well, we know we're starting with 5, and we're adding the common difference a certain amount of times. And how many times are we adding the common difference? So let's analyze the relationship between the number of times we're adding the common difference and the value of n, the term number. So if in the first term we're adding the common difference 0 times, second term we're adding the common difference 1 time, the third term we're adding the common difference 2 times, so it seems like we're always adding the common difference 1 less times than the term number. So how would we write 1 less than the term number? Well, we write the term number and then we subtract 1 from it. And generalizing this form, or we can say that the nth term of this sequence is going to be 5 plus 2 times the difference of n minus 1, or n and 1. If we want to generalize this formula to all sequences, we can say that this is just the first term in the sequence, the first term, and this number is going to be the common difference. The common difference. And so this can be generalized to all sequences by writing a sub n, or the nth term, is a sub 1, or a1, the first term in the sequence, plus the common difference times n minus 1. And that is the formula for an arithmetic sequence.